Hello guys, how are you today? So today I'll be explaining the Math AMS quiz of Term 1, Week 9. So without further ado, let's get started. So, the graph of the function fx equal x cubed minus 12x is increasing. How do we know it is increasing? Very simply, we'll need to find the table of variation. How do we find the table of variation? We need to take the first derivative. So let's take the first derivative from this. It's going to be 3x squared minus 12. Now let's find the roots together. So we're going to make it equal to 0. That means 3x squared is equal to 12. X squared is equal to 4, so x is what, plus or minus 2. So if we put it in the table of variation, it's gonna be negative 2, positive 2, right? So negative 2 will choose a number less than it, a number in between minus 2 and 2, and a number greater than 2. Okay, so if we chose, for example, negative 3 and we substitute it in this equation, we're gonna get a positive value. If we chose 1 and we substituted it in this equation, we would get a negative value. If we chose a number greater than 2, for example, 3, and we substituted it in this equation, we're gonna get a positive value. So it's increasing, decreasing, increasing. What does this mean? This means this function is increasing for all values less than minus 2 and greater than 2. So this is basically what we just said. Any number less than minus 2 or greater than 2. We move on to question number 2. What does it say? It says, given the following sign table for the first and second derivatives of y equals fx, which of the following is true? So before we look at the answers, let us read whatever we have. So the first thing we have is the first derivative. The second thing we have is what is the second derivative. From the first derivative, we can know whether we have stationary points, right? So here we have stationary points. Okay, after stationary points, we can know if we have a local maximum, local minimum, or a saddle point, right? Whereas in the double derivative, we can know if we have any inflection points, and we can know where and when the signs change, like whether it goes from positive to negative, or from negative to positive. So let us read this together. First thing we can see is that from minus 3, you choose any number that's smaller than minus 3, you're gonna get in the first derivative a negative answer. Then, any number in between minus 3 and 0, for example, minus 1, it will give us a positive answer. Or, any number between 0 and 3, that's gonna give us 1. Right? For example, 1, it's going to give us a positive answer. And then any number greater than 3 will give us a negative answer. So what can we say in this scenario? We say this is decreasing, then increasing, increasing, then decreasing again. So what do we call this point over here? This point over here is a local minimum. This point over here is a local maximum. And this point over here, because they're both going up, right? What do we call this? We call this a saddle point. So this is basically everything for the first derivative. For the second derivative, we see that they are all positive. If they're all positive, that means there's no inflection points and there's no change in the sign. So what does this mean? This means we have a saddle point at 0, we have a local minimum at minus 3 and a local maximum at 3. So local maximum at 3 and a minimum at minus 3. Perfect, we'll move on to question number 3. What does it say? In question number 3, it says, fx has a point of inflection at x equal to a. What did we say about inflection point? It means that this is the point where there are changes in the sign. So changes in sign. And we also know in the inflection point that the double derivative, that means f double prime of a, is equal to what is equal to 0. So very simply, inflection point is when the double derivative of a is 0 and when the double derivative passes through the point A and then f of A means y, right? So for every x there's a y, so this is A and the y of A, okay, there will be a change in sign. Yes, this is correct. This is basically the definition, like these two are basically the definition of an inflection point. Perfect, we move on to question number 4. A curve is described by the equation y equals fx, where fx is 4x plus 10 over x. They told us the value of dy over dx, the derivative, at the point where x is minus 1. So first thing, what are we going to need to do? We need to find the derivative. So 4x plus 100 over x, how do we find the derivative of this? We find the derivative of this and we find the derivative of this alone. So this is going to be 4, right? And this is going to be what? This you can take it as 100x to the power of minus 1. So take the derivative from here. It's going to be minus 1 times 100 x to the power of minus 2. So it becomes minus 100 over x squared. So now it's 4 plus minus 100 over x squared. So let's substitute in the x minus 1. What's it going to be? It's going to be 4 minus 100 over minus 1 squared. Don't forget the brackets, they're very important. When you put it on the calculator, you will get an answer of minus 96. Perfect. Now they're saying the double derivative, so now we need to do another derivative. What did we get the answer last time? 4 minus 100 over x squared. So if you do the derivative, you'll need to do the derivative of this alone and the derivative of this alone. So this will go bye-bye because the derivative of any whole number is 0. Right? And now we're left to find the derivative of this. So minus 100 times x to the power of minus 2. Bring it down. It becomes minus 100 times minus 2, right? X to the power of minus 3. Okay? So then, what's it going to be? It's going to be 200 over x cubed. So if we will need to substitute minus 1 now, it's going to be 200 over minus 1 cubed. So that's going to be minus 200. Perfect. We'll move on now to point C and D. They want the local minimum and local maximum. How do we find the local minimum and local maximum? We very simply need to take our first derivative. What was the first derivative? It was 4 minus 100 over x squared. And we need to solve it equal to 0. How do we do that? You just multiply everything by x squared. So you will not keep it in the denominator. We can't keep it in the denominator. So in this scenario, it is what? It's 4x squared minus 100 is equal to 0. So we're going to need to solve this, right? So 4x squared is equal to 100. X squared is equal to 25. That means x is plus or minus 5. Now we need to do the table of variation based on these. Minus 5 plus 5. Choose a number smaller than minus 5. It's going to give us a positive answer. Choose a number in between minus 5 and 5. It's going to give us a negative answer. And then choose a number greater than 5, it's going to give us a positive answer. So it's increasing, decreasing, increasing. That means we have a local minimum at 5. And now let's find the height. How do we find the y? Let me just go up. There we go. How do we find the y? We'll need to substitute 5 in this equation over here, which is the original equation. So 4 times 5 plus 100 over 5. So how much is that going to be? That's going to be 40. That means it's 5 and 40, right? And that means we have what? We have that we have a local maximum at this, a local maximum at this point, which is what? Which is minus 5. And how do we find the y? You just substitute minus 5 in the equation. So it will be 4 times minus 5 plus 100 over minus 5. So what's that going to be? That's going to be minus 40. So very simply, it's going to be 540. The local minimum and local maximum is minus 5 minus 40. We move on to part E. If you remember in the table of variation, what did we have? We had minus 5, 5. We had positive, negative, positive. So now, very simply, how are we going to denote this? We're going to have two values, right? A value over here and a value over here. We're going to put a comma in between them. The value to the left, because we have the left and the right, left and the right. The value to the left is the minimum value. So it's the least possible value for what? For increasing. So we start here, it's minus infinity, right? Plus infinity. So the left side is the minimum value, the least possible value that we can place for it to be positive. So For example, we can say minus infinity, right? And for the left, we can take 5, right? Because look, we have two intervals where it is what? Where it is positive here and here. So you always take the minimum or the least possible value. You put it on the left side. So minus infinity and 5. Now, what about the right-hand side? In the right-hand side, you're going to take the maximum possible value. That means it's going to be minus 5 and plus infinity. All right? So if we're looking for a possible answer, it would be this one over here. Why? Because look what happened. We said that it would be minus infinity minus 5 plus infinity, and they put instead of minus 5 and 5, they put instead of it minus a and a. Why? Because in the next part they want us to write the value of a, and we know that the value of a is what? The value of a is 5. So that is it for question number 4. We'll move on now to question number 5. So now, question number 5. The surface area of a cylinder with base radius r and height h is given by this. Its volume is given by this. If the volume is 3,456 pi centimeter cubed, then the surface area in centimeter squared can be expressed as this. So very simply, look what we need to do in this scenario. What did they substitute over here? They substituted the height, right? So they kept all of the r's, but the only thing they substituted was the height. So what does this mean? This means we need to find the value of the height h. We know that from this equation, v equal pi r squared h, we can make h the function of the equation. So h is equal to v over pi r squared. What's the volume? The volume is 3456 pi over pi r squared. So this and this cancel, and we're left with 3456 over r squared. Now what do? We substitute it in the equation of s. So 2 pi r h, instead of h you put 3456 over r squared plus 2 pi r squared. Now this and this will cancel. Then 2 times 3456, that's gonna be what? That's gonna be 6912. So very simply, the value of b is what? It's 6912. Okay, so over here we have it to be 6912. We move on to part B. It says the radius r for which the surface area is minimal. How do we find this? Very simply, we need to do what? We need to do a table of variation. How do we do a table of variation? Very simply, we'll need to take the derivative of this. Let's take the derivative of this. If you take the derivative of this, you are gonna get, first of all, remove the pi, because the pi is gonna make everything a bit more complicated. So when you're doing the derivative, you remove the pi, right? And what are you gonna get? You're gonna get minus 6,912 over r squared. I already did this from before. This is why I know the answer. But you'd basically do the derivative of this, and then you add it to what? You add it to 4r. Now, remember, we can't have r squared in the denominator. We can't have anything in the denominator, actually. That is r. So we'll multiply everything by r squared. Just like that, we're going to get what? We're going to get 6912 plus 4 r times r squared, so 4r cubed. It's equal to 0. You'll need to move this to the other side. 4r cubed is equal to 6912. Divide both sides by 4. You're gonna get r cubed is equal to what? Is equal to 1728. So you do what? You do the cubic root of this. Remember, this is cubed, not squared. You do the cubic root of this, and you will get an answer, which is what? You will get an answer, which is that r is equal to 12. Now, how do we check if this is the minimal surface area? Again, as we said, we're going to do the table of variation. So we'll go by 12, right? Let's choose a number smaller than 12, for example, 1. Substitute 1 in the equation, and you're going to get a negative answer. Choose a number greater than 12, for example, 20. Substitute it in the equation, you're going to get a positive answer. So as you can see, this is decreasing and this is increasing. So this is what? This is the minimal value for r in which the surface area is minimal. The answer over here is what? Is 12 centimeters. Perfect. We move on to question number 6. The surface area of a cylinder with base radius r and height is given by this. Okay, they told us if the volume is 2000 pi, then they want the value of the height. So volume is pi r squared h. So h is volume over pi r squared. So it's 2000 pi over pi r squared. So you remove pi and you remove pi as well. So it's 2000 over what? Over r squared. All right, so that's the first part done. We got it to be 2000 over r squared. Now, in terms of r only, they want us to substitute it in the surface area. So it's going to be 2 pi r times 2000 over r squared plus 2 pi r squared. So what would we need to do in this situation? In this situation, again, we're going to do like last time. We're going to multiply by 2, so it becomes 4000 over r plus 2 pi r squared, right? Right, so let me put over here 2000 over r squared and then 4000 pi over r plus 2 pi r squared. Now, they need the derivative, so we're going to take the derivative of this. So basically, I'm going to leave the derivative up to you guys. It's going to be minus 4000 pi over r squared plus 4 pi r. So over here, it's what? Minus 4000. Now, what do they want? They want us to make the derivative equal to 0. So if we make it equal to 0, it's minus 4000 pi over r squared plus 4 pi r, right? When we're solving, we remove pi because it's going to be a bit complicated with the pi, so we're going to remove pi. Now, we don't like to see r in the denominator, so what do? We will multiply everything by r squared. So what is it going to be? It's going to be minus 4000 plus 4r cubed, right? So now you're going to make this equal to 0. It's going to be 4r cubed equal 4000, r cubed equal 1000. That means r is equal to 10. Now, they said the second derivative is always what? So let's take the second derivative from this. After doing it, you're going to get 8000 pi over r cubed, right? 8000 pi over r cubed plus 4 pi, right? Now, what do we do in this scenario? When we're solving, we remove the pi because it's going to be complicated. Now, what do we multiply by? We'll multiply by 3 to the, r to the power of 3, r cubed, because we don't like to see it in the denominator. So now we're going to be left with 8000 plus 4r cubed. Now, they said is always what? What do they mean by the second derivative is always what? What do we do in this scenario? We got r from the previous question, which is what? Which is 10. If you substitute it in the second derivative, which we got to be 8000 plus 4r cubed, or no, actually, let's leave it as 8000 over r cubed plus 4. So if you substitute 10, okay, in the second derivative, what are we gonna get? If you substitute it, let's try on the calculator. 8000 over 10 to the power of 3 plus 4, you are gonna get 12. And 12 is what? 12 is a positive answer. So when we substitute 10 over here, we can say officially that it's always gonna be what? It's always gonna be positive. So because it's always gonna be positive, what does this mean? This means the minimum surface area. So positive is minimum, whereas negative is maximum. Okay? So the positive is gonna be minimum, right? So the minimum surface area is attained at which of the following? At when r is 10. Very simply. So it's always positive. So it's minimum always when r is 10. We'll move on to question number 7. Question number 7. Consider the curve C, whose equation is given by y equal x cubed minus 18x squared plus 81x minus 108. They want us to take the derivative, so we take the derivative. It will be 3x squared minus 36x plus 81. So over here we will put 36. Now, they want us to factorize it. They want us to factorize this. So how do we factorize this? First of all, we will take out 3. When we take out 3, it becomes x squared minus 12 plus 27. Now, you can factorize this even more by doing mod 5 of 3. So it will be 1 minus 12, 27. And you will get two values, which are x is equal to 9 and x is equal to 3. So what does it mean? If you move it to the other side, that means it's x minus 9, x minus 3, and don't forget about the 3 outside. So they already put 3 and minus 3. What's left for us is minus 9. That means already over here we have 36, and b is what? B is 9. So they already did the table of variation for us, right? It's 9 over here. So it's increasing, decreasing, increasing, meaning it's a local maximum at x being 3 and a local minimum at x being 9. Now, we move on to question number 8. What does it say in question number 8? The function f is defined by this, where c is a non-zero constant. The roots of the equation fx equal to 0 are r and minus 4r, where r is a positive constant. fill in the blank with the correct integer. They want to find the value of r. Do you remember from previous years? Do you remember that the product of the roots is equal to c over a, and the sum of the roots is equal to minus b over a. So we can say that minus 4r cubed is equal to c over a, and a is 1 in the scenario. So basically, minus 4r cubed is equal to c. And then minus 3r is equal to minus b over a. A is 1, and what is b? B is 12. That means r is equal to what? R is minus 12 or minus 3, which is what? Which is 4. Now, where do we put it? We put it over here. So minus 4 times 4. Sorry, this is squared, not cubed. So minus 4 times 4 squared. This will give us an answer, which is equal to c, which is what? Which is minus 64. So now we have the value of r, which is 4, and we have the value of c, which is what? Which is minus 64. So 4 and minus 64. We move on to part C. In factored form, so what do we need to do? We will need to find the roots of x squared plus 12x minus 64. You can do that by doing mod 5, 3, and you're going to get 1, 12 minus 64. And what are the two roots you will get? You will get two roots, which are 4 and minus 16. That means x is equal to 4 and x is equal to minus 16. So if you move them to the other side, x minus 4, x plus 16. Right, so x minus 4, x plus 16. We move on to part D with the coordinates of the turning point. So what does it mean, turning point? Turning point means we need to find a point where it goes from increasing to decreasing. So what can we do in this scenario? We need to take the table of variation. How do we take the table of variation? Very simply, we need to find what? We need to find the first derivative. So let us find the first derivative together, right? It's x squared plus 12x minus 64. So take the first derivative, 2x plus 12, that means x is what? X is minus 6. There's only one value for x, that means what? That means this is what? This is the turning point, minus 6. Now, how do we find its y? We need to substitute it in the original equation, so x squared plus 12x minus 64. We said that x was what? Was minus 6, so we will substitute it with minus 6. So it's gonna be minus 100. So very simply, the answer over here is what? Is minus 100. We'll move on to question number 9. What does it say? It says the volume V of an open box, so the square base of side x centimeters is 810 centimeter cubed. For x equals to 9 centimeters, they want the area of the base. We know what? We know that it has a square base. So how do we find the area of a base? Very simply, it's going to be side times side, which is 9 times 9, which is what? Which is 81. Now the height of the box, we know it's a square, like it's a volume of a square base box, right? So it's gonna be x times h, width times length times height. So we already have x times x, which is x squared, which is what? Which is 81. It's times the height will give us the volume, which is 810. That means the height is what? The height is 10 centimeters, right? So 81 and 10. We'll move on to question number 10. The curve whose equation is given by this has a local maximum and local minimum. How do we find local minimum and maximum? First thing we need to do is take the derivative. So take the derivative of this. It's 3x squared minus 6x, right? So you can take x out as common. So x times 3x minus 6, that means the two roots are what? The two roots are x equals 0 and x equal 2. Now, we need to do what? We need to do a table of variation, right? So table of variation, 0 and 2. If you choose a number less than 0 and you substitute it in 3x squared minus 6x, you will get a positive answer. If you choose a number in between 0 and 2, you would get a negative answer. And if you chose a number greater than 2, you would also get a positive answer. So as you can see, it's increasing, decreasing, increasing. So we have a local maximum at 0. And what's the value of y at 0? You will need to substitute it in the original equation and you will get an answer of 13. And it has a local minimum at 2. So how do you find the y of 2? You need to substitute it in the original equation. So that's 2 cubed minus 3 times 2 squared plus 13. So that's going to be 9. So it has a local maximum at 0, 13, and a local minimum at 2, 9. So at 0, and the value there is 13, and it has a local minimum at x equals to 2. They want the value of the inflection point. How do we find inflection point? We need to do the double derivative, right? So let's take the double derivative of this. It's gonna be 12x squared. That's it, 12x squared. Then we do the derivative again. It's gonna be 24x. Now you need to make it equal to 0. What's the only value of x that will make this equal to 0? 0. That means we have an inflection point at what? At 0. But we need to check first of all by doing a table. 0. Choose any number less than 0. Substitute it in the equation. When you get a positive or negative answer, a negative answer for sure. Now choose any number greater than 0. For example, 1, substitute it, you're going to get a positive answer. So yes, from the second derivative, there is a change in sign. That means we can say it is what? It is an inflection point. We move on to question number 12. What does it say? It says a square of side x centimeter is removed from each corner of a square cardboard box. Let's see. Okay, we have it like this, like this, like this, and like this, right? So we have from here, from here, from here, and from here. They removed what? X, 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 x. Basically, they removed the x, right? Now, we know that this was originally how much? It was originally 30, and this was also originally 30. So if we removed x from one side and x from the other side, it's gonna be 30 minus, how many x were removed? 1 and 2, so 30 minus 2x. Now, remember that, how do you find the volume of a box? It's gonna be width times length times height. So first we took the width, which is 30 minus 2x. Now the length, which is also 30 minus 2x. And then last but not least, we will multiply it by what? We will multiply it by the height, which is x. So this is very simply the volume of the box that we are dealing with. Now you only need to expand it. So when we expand it, it's gonna be 900 minus 120x plus 4x squared, all of it multiplied by x. So then it would become what? It would become 4x cubed plus 120x squared plus, no, sorry, minus 120x squared plus 900x. Right now we have what? Now we have the volume. So they want us to find the value for x for which the volume is maximum. How do we do that? We need to take the derivative. So take the derivative of this. It's gonna be 12x squared minus 240x plus 900. Now what do we do in this scenario? We need to find the roots, okay? So 12 minus 240, 900. We will get two roots, which are what? Which are x is equal to 15 and x is equal to 5. Now, after this point, we'll just need to make a table of variation. 5 and 15. If you put any number less than 5, it's positive. Any number in between 5 and 15, it's negative. And any number greater than 15, it's positive. So it's going up, then down, then up. And what do they want? They want the value for which the volume is what is maximum. So how do we find the value for which the volume is maximum? Very simply, 5. Why? Because it's a local maximum. So that means the answer is what? The answer is 5 centimeter. We move on to question number 13. What does it say? It says, consider the function given by gx equal x squared minus 2x minus 15, all of it to the power of 4. The value of the gradient of g at the point where x is equal to 0 is. What does this mean? They want us to take the gradient of this, right? So x squared minus 2x minus 15 to the power of 4. Let's take the gradient. How do we find the gradient? First of all, we'll need to take the derivative. So it will be 4 times x squared minus 2x minus 15 to the power of 3. And don't forget to multiply by the derivative of what's inside, which is 2x minus 2. Now, what do? We substitute x by 0. So it's gonna be 4 times 0 squared minus 2 times 0 minus 15, all of it to the power of 3. Then 2 times 0 minus 2, and you will get the answer, which is 27,000. Now, the function g has how many stationary points? very simply, what do we need to do? We will need to find the roots of this. Here it's only one root, and where x is equal to 1. Here it has two roots, which are what? Which are x is equal to 5 and x is equal to minus 3. So now we have what? We have 3 stationary points. How do we know? Very simply, because we got 1, 2, 3 roots. So this has how many stationary points? It has 3 stationary points, okay? Now, they want us to find local minimums and local maximums, so we need to do the table of variation, but now with 3 values. So minus 3, 1, and 5, right? So now, choose a number less than minus 3. For example, let's take minus 6. A number in between minus 3 and 1, for example, minus 1. A number in between 1 and 5, for example, 3. And a number greater than 5, for example, 10. And we'll substitute it in this equation over here. Substitute minus 6 in the equation. It's gonna be 4 times minus 6 squared minus 2 times minus 6 minus 15, all of it to the power of 3, times 2 times minus 6 minus 2. It will give us what? A negative answer. Now let's substitute minus 6 with minus 1. That's gonna give us a positive answer. Let's substitute minus 1 by 3. And that's gonna give us a negative answer. Let's substitute it by 10 now. If you substitute it by 10, you will get a positive answer. So as you can see, it's what? It's decreasing, then increasing, then decreasing, then increasing. That means we have 2 local minimums, which are minus 3 and 5. And 1 local maximum, which is at what? Which is at x equal to 1. So this is 27,000, 3 stationary points, minus 3 and 5, and then x being equal to 1. We move on now to question number 14. So now, question number 14. Part A, the function attains a local minimum and a local maximum. How do we do this? There's 2 ways to do this. First of all, you could actually, like, you could put minus 55 is equal to this, right? And you'll be able to find the value of x after like a lot of solving. This is one way to do it. Now, a second way to do it, which I believe is like much easier, is to do a table of variation. In order to do that, you need to do what? You need to take the derivative, which is 3 times 2, that's 6, my bad. 6x squared plus 12x minus 48, right? Now we'll need to take the roots of these. Mod 5, 3, 6, 12 minus 48. You will get what? You will get x equals to 2 and x equals to minus 4. So minus 4, if I'm not mistaken, yeah, and 2. Now, if you choose a number less than minus 4, it's gonna be positive. If you choose a number in between minus 4 and 2, it's gonna be negative. And if you choose a number greater than 2, it's gonna be what? It's gonna be positive. So it's going up, then down, then up. So as you can see, there is a local minimum at point 2, and you can substitute 2 over here and you will get an answer of minus 55. And there's a local maximum at minus 4, so you'll put minus 4 over here. You can substitute minus 4 as well in the equation over here and you will get 161. So it's 2 and minus 4. Now, concave up and concave down. How do we find concave up and concave down? We need to take the second derivative. So the first derivative is 6x squared plus 12x minus 48. Then the second derivative is 12x plus 12. That means x is equal to minus 1. Now, we'll need to do what? The inflection point, but based on minus 1. If we choose a number less than minus 1, for example, minus 2, is our answer gonna be positive or negative? For sure, it's gonna be negative. If we choose a number greater than minus 1, for example, 0, 5, 10, 1,000, whatever number greater than minus 1, you substitute it in this equation and you're gonna get what? You're gonna get a positive answer. So as you can see, it's only concave down if it's less than minus 1 and concave up if it's greater than minus 1. So we put minus 1 here and minus 1 here. It's concave up only if it is greater than minus 1 and concave down only if it is less than minus 1. We move on to question number 15. What does it say? It says, given the following sign for y equals fx, okay? And they told us, very important, very, very important, they told us that if x is equal to 0 for x being minus 4, 0, and 4. What does this mean? This means that y is equal to 0 for x being equal to 4, minus 4, sorry, 0, and 4. That means we call these the x-intercept. So we have an x-intercept at these 4 points, okay? Now we go up to the graph. What do we see? We see that they gave us y prime, meaning the first derivative, and y double prime, meaning the second derivative. From here, what can we determine? We can determine that minus 3 is a local minimum, minus 1 is a saddle point, 0 is a local maximum, 1 is also a saddle point, and 3 is what? 3 is a local minimum again. What can we tell from the second derivative? We can tell that minus 1 is an inflection point, and 1 is also what? Is also an inflection point. Okay? So, based on all of this information, let us go down and see. So, first thing we should know is that minus 3 minus 5, it's gonna be what? It's gonna be a local minimum. So at minus 3 minus 5, we need to find, first of all, which ones have minus 3 minus 5. These two are out because they don't have minus 3 minus 5. However, these two, this one and this one, are still in y because they both have the option of minus 3 minus 5. Okay? And both of them, minus 3 minus 5 is what? Is a local minimum. After that, we have minus 1 being what? Being a saddle point. You go to minus 1, which is over here. It is, yes, a saddle point. You go also over here to minus 1. It is as well a saddle point because it's still increasing and increasing. Then, at 0, 0, it's what? A local maximum. So between these two graphs, we need to see which one is 0, 0 a local maximum. Is 0, 0 a local maximum over here? No. So directly we cross it out. And we're left with this graph over here. Because we know that, first of all, minus 3 minus 5 is a local minimum. 0, 0 is a local maximum. And I believe 3 minus 5, yeah, 3 minus 5 is also another local minimum. So as you can see, it's definitely for sure this one over here. So let's submit and hopefully we don't have any mistakes. And perfect, thank God we don't have any mistakes. Thank you guys for watching. I hope you enjoyed and have a wonderful